are the 2 points where the ring will fall. So according to the coordinate system, if I say the first one is falling on the first quadrant and the second one is falling on the third quadrant. Okay, now only thing is that you have to get the coordinate of these 2 points. Now how to get that? Now this is the origin. Hello and welcome my dear student. So in this lecture series, I am going to solve some of the interesting and challenging numerical problems based on the concept of work power energy. So let us start with the system. So here there is a ring of mass m, small m, slides on a smooth vertical rod. So this is the vertical rod. So along that the ring is sliding. So there is a light string attached to the ring, passes over a smooth peg at a distance of a from the end. And it is again passes through a pulley. To that pulley, the capital M mass is held. So it is given that the mass of capital M is greater than small m. So the ring is held on a level with the peg and released. Okay. So once it is released, so ring is tries to move in the upward direction. And ultimately, let us say one point will come when the ring is over here. At this position, ring is there, and the mass is fallen below by certain distance. Let us say that is h. Okay. Now you are asked to calculate that. So the distance traveled by the ring before coming to rest is this. So you have to prove this. Okay. So let us say, so at the final position, this is the position of the ring, and this is the from where the pulley is there. Let us say the string is like this way, passes over a pulley, and the mass is resting over capital M, and this is the small m. Let us say at that instant, the A capital M has fallen by a distance of, let us say this much height is h. And similarly, the small m is raised to a height of small y, let us say. Okay. So since it is given that both of them are at rest, that means the kinetic energy of the system becomes 0. So that means it means the potential energy is also to be 0. Now potential energy is 0 means one of the system must gain the potential energy and another of them must lose the energy. So in this situation, what is happening? Small m mass is raised by a height of y, and let us say the capital M is dropped down by 8. So I can say here the capital M will lose the potential energy, and here the small m will gain the potential energy. So total loss and gain must be equal. Okay. So for the system, what I can write that if I say small mgy is the gain in the potential energy, that should be equals to capital mgh. Okay. So from here, what I can write that small h is equals to basically small m divided by capital M into y. Okay. Now let us do another equation between x and y. Between y and h. Let us say this length is L. So initially the gap between these two things is that A. So h can be written as the L minus A. So this is the length of the capital M that has been dropped below the horizontal line. Okay, so let us say this is our reference line. So from this reference line, the capital M is dropped by this distance h, that is equal to small l minus a. So what you can write that small l is equals to again under root of y square plus a square from the right angle triangle geometry. So now I can do another equation where I am saying that h equals to l minus a, or so I am getting h equals to L minus A, or L equals to A plus A. Now squaring both sides, what I get, L square equals to h square plus A square plus 2 times of h into A. Okay. Now L square equals to how much? L square equals to under root of y square plus A square whole square. So that means y square plus A square. Y square plus A square, that should be equals to h square plus A square plus 2 times of h into A. So this will cancel out. So ultimately we are left with h square. This number should be equals to y square minus 2ha. Okay. Now I am going to use this equation over here. So if I square both sides, so I am getting h square should be equals to small m by capital M whole square into y square. Now simply substitute the value of h square as y square minus 2ha. So once I write y square minus 2ha should be equals to small m by capital M whole square into y square. So take y square on the other side. So I can write y square common. So it is 1 minus small m square divided by capital M square equals to 2 times of h into a. Now what is h? H is basically our m by m into y. So if I put this h over here, so I can further simplify it as that should be equal to 2 times of a into 8. 8 means small m by capital M into y. So ultimately y will cancel out from the other side. So we are left with the number y. Okay. So ultimately what I am getting, so if I simplify it further from this point, so one y has been cancelled out into 1 minus small m square by capital M square. That should be equals to 2 times of a into small m by capital M. So on further simplification, I can say that this number comes to as y equals to 2 times of small m capital M into a here by capital M square minus small m square. Okay. So that will be your final answer. That means this is the distance that has been moved by the small m mass before coming to apex. Hope you understand this. Now moving on to the next situation. So there is a spring gun. Okay, this is a spring gun having a spring constant of 100 Newton per meter is given. A small ball B of mass 100 gram is put in the barrel compressed by a distance of 0.5 meters. So there is a spring and you push the barrel, push the ball by a distance of 0.05 meter. So that now once we release it, so ball will follow a projectile path. So what is the situation? Situation is like this here. So this is the box inside which the spring is being there. Okay, let us say this is the natural length of the spring. Okay, so once I push the spring by a distance of, let us say this distance is given as 0.05 meter. 0.05 meter. Once I push this, so that means the ball is over here. Now once I release it, so ball will get the kinetic energy. With that kinetic energy, the ball is performing a projectile motion and you are asked to calculate the position where the particle will fall on the ground. Okay, let us say this is the distance d that you want to calculate where it will hit the ground. Okay, so simply it is a problem of projectile motion. I know that once the spring is being compressed, so what I can say that half kf square is the potential energy that is inside the spring. That should be equals to half mv square, gaining kinetic energy of the block. So if I calculate that, so that means v square should be equals to how much? K x square by m. Okay, so that means it gives v equals to under root of k x square by m, or I can say x into under root k by m. So this is the velocity with which the ball is coming out of the spring. And it is also given that this is the vertical height, that height is given as 2 meter. H is given as 2 meter. So this is the vertical distance fallen by the ball. So from the basic projectile equation, what I can say that H is the distance traveled in the vertical direction, and since there is no velocity in the vertical direction, so I can write H equals to simply half g distance. Okay. So from that t should be equals to under root of 2h by e. So this is the time taken by the particle to fall on the ground. And in that time, how much distance it has been traveled? That should be equals to d plus this 0.5. That should be equals to our total distance, that is v into t. So what is v? That is x into under root of k by m into t. Okay. Now all those parameters are known. Simply put the values and get the result. So x is how much? That is 0.05. That is 5 by 100. Root of k. K is how much? K is given as 100. Divided by mass. Mass is 100 grams. So 100 and by 1000 over here. Okay. And t is there. What is t? T is the time. So time is how much? Under root of 2h by g. So under root of 2, h is 2 meter by g is 10. Okay, so ultimately what happens? This 100 cancels out. This 10 cancels out with 100 into 4 means 10 into 2. 10 into 2 means 20. So 20 into 5 means 100. So 100 by 100 is 1. Okay, so 1 meter. So this is the distance. So d plus 0.05 is equals to 1 meter. So it is not clear that what distance that you have to calculate. So the answer was 1 meter because it is the numerical answer. So D is the 1 meter. That is, this is the total distance they are asking for, that is D prime. Okay. So that is equals to 1 meter. Okay. Now moving on to the next situation. Here there is a 0.5 kg block slides down the point A on a horizontal track. So this is a horizontal track with an initial speed of 3 meter per second. So it has the initial speed of 3 meter per second and it is moving towards the spring, whose horizontal length of the spring is given as 1 meter and the K value is given. The part AB of the track is frictionless. So this part is no friction. Now from point B, the friction part is there. So BC has the coefficient of static and kinetic friction of 0.22 and 0.2. So BC has the coefficient of static and kinetic friction given as 0.22 and 0.2 respectively. You are asked to calculate the total distance through which the block moves before it comes to rest completely. Now you have to understand the question carefully that you are asking for the total distance. So I have to check it whether it will move further or not. So initially what is happening? So if I say the spring is compressed from the point D, let us say by a distance of x. So here the spring is there and is being compressed by a distance of x, and at that position of time, the block is at rest. So this block, if it is touching the spring, will be at rest. So V equals to 0. And that distance is, let us say, the x distance. So x is the compression of the spring. So first we calculate what is the compression. And for that, what is the work done by the friction? So work done by the friction is this much. That is 2.14 plus x. Okay. And if I write the conservation of energy equation, so what I can write that work done by friction should be equal to K final plus U final minus A initial plus U initial. That is our equation. Now what is the final kinetic energy? Final kinetic energy is 0. Potential energy, spring is being compressed by a distance of half kx square. So corresponding to that, the energy of the spring is half kx square minus initial kinetic energy is half mv square, that is given, and initial potential energy is also 0. And what is the work done by the friction? For the entire path, work done by the friction. So here the friction force is how much? That is basically equals to mu into mg. Now what is that mu? That is the kinetic coefficient of friction, mu k, because the part is moving. So it is mu k into mg into 2.4 plus x, because that is the total distance traveled by the block. So that is the work done part coming under the friction. So here I can write that total work done by the friction equals to minus mu into mg into 2.14 plus x. That should be equals to half kx square minus half mv square. Okay, now put all the values. So mu is given as 0.2 and m is 0.5. So it is equals to 0.2 into 0.5 into 10 into 2.14 plus x equals to half kx square. K is given as 2. So half into 2 into x square minus 0.5 into v square. V square is how much? 3 square is 9. So 9 by 2. Okay. So it is 4.5 into 0.5 means here it becomes minus 2.25. Now it is equals to x square. Now 0.5 into 10 is 5. 5 into 0.2 means 1. So minus 2.14 minus x. So moving on to the another side. So x square plus x minus 0.14 and 0.25 means 0.11. 0.11, that should be equal to 0. Okay, so that gives the quadratic equation x. So I have to solve that. So what is that solution? That is basically x equals to minus b means minus 1 plus minus root of b square means 1 minus 4 AC means 0.44 by 2a means 2. So 1 plus 0.44 means 1.44, that is 1.2. So that means minus 1 plus minus 1.2 by 2. So I have to take the positive one. So 1.2 minus 1 is 0.2 by 2 means 0. So 0.1 meter is the compression of the spring before it comes to rest. Now what happens after the compression takes? Now once the spring has been compressed, so on that block, the spring is offering a force of kx. What is that force? That force is equal to k is given as 2 into 0.1. That means 0.2 Newton. So that is the force offered by the spring. Now here, what is the maximum value of limiting friction? So limiting friction is mu s into n. Mu s is how much? 0.22. 0.22 into n is 5. Okay, so that means it is greater than 0.2. Okay, so 0.22 into 5 is how much? 0.22 into mu s into n. So n is 5. So 0.11. So 0.22 into 5, that gives how much? That comes to as around 1.1. So 1.1 Newton is the limiting value of the friction. That is the maximum possible value of the friction that can be offered by the flow on the block itself. But spring is offering a force of k. So since the kx value is less than the limiting value of friction, so block will not further move. If in the question the kx is more, then the block will again move. So ultimately it will come after some another distance. But now at this point the block will come permanently stop. So your answer to calculate the total distance is basically 0.1 meter. So that is your answer. Okay, hope you understand this. Thanks for watching. Now moving on to this problem. So there is a string with one end fixed on the rigid wall. So this is the fixed end with the rigid one. Passes over a frictionless pulley and there is a two block system with there, capital M and small m. So mass of capital M is given as 2 kg, mass of small m is given as 0.5 kg. So the distances of the pulley is given as 2 meters. So this distance is given as 2 meters. This distance is given as 2 meters. And 1 meter from the wall is that is the distance of the capital M. Okay. Now once the system is released, so you are asked to calculate the speed with which the capital M will hit the wall when the small m is being released. Now when the capital M is being released, so ultimately if I see this is the final diagram, so this is the fixed point. So this is the fixed point where the rope with the 1 kg mass is fixed. So if I say this is the one part of the rope, now here the block M is hitting the wall. Capital M is hitting the wall. So with another part of the rope is like this way. So this is passing over the pulley and goes to another mass small m. Another mass small m. Okay, that is the situation. So total length of the string is always constant. So in this situation, this is the 1 meter height has been dropped. And what is that? That is a 2 meter. Okay, this is a 2 meter. So initially, let us say this is the block is at a distance of x1 length from the pulley. Now it comes to x2 length. X2 length. Okay. Now what is the hypotenuse length? That hypotenuse length is 2 square plus 1 square is root 5. So this is the root 5 meter. Okay. So total length of the string is how much? 1 plus root 5 plus x2. 1 plus root 5 plus x2 in the final situation. That should be equal to the initial situation. Initial situation is 2 plus x1. 2 plus x1. So that means root 5 plus x2 should be equal to 1 plus x1. Or I can write x1 minus x2. That should be equal to root 5 minus. Okay. So that length has been dropped by the small m mass. Okay. So x1 minus x2 is root 5 minus 1. So it is being released. So x2 is less than x1. So that means the small m is raised by this much distance. Okay. And capital M is dropped by that much distance. So can I say that gain in potential energy or gain in kinetic energy should be equals to loss in potential energy. Because no other forces are existing over here, only the conservative forces are there. So I can use this equation. So what is the total gain in kinetic energy? That is equals to half capital A into V square plus half small m into V square. That is the gain in kinetic energy. and that should be equal to loss in potential energy. So loss is due to plus M, because I am saying once I am saying loss of energy, so I am taking the loss as a positive number. So capital M has been lost by 1 meter. So capital mg into 1 meter, and small m is elevated by a distance of root 5 minus 1. So that is mgh minus small mg into root 5 minus 1. Okay. So put all the value and you can go for the solution of this equation to calculate the V value. Okay. So that will give you your answer. Hope you understand this. Now moving on to the next equation. So there is a small bead of mass small m is free to slide on a fixed smooth vertical. So this is the vertical wire on which there is small bead is attached at point B and is connected with a string whose some elastic string it is given of unstretched length is A is the unstretched length, and force constant that is given as 2 mg by E is attached to point B. Okay. So bead is connected with the string, elastic string, and then the string passes through the point R. So R is another point, and then connected with the Y like this. Okay. So all the values are given, that is AR number equals to RO equals to A that is given. So you are asked to calculate the equilibrium position, the value of OB. So once the bead is at this position, now you are asked to calculate this Y naught number. Let us say this is the distance of Y. So this is the equilibrium position value. Okay. Now here what is happening? So this is the total length of the string. What is the total length? So if I say this is the L, so this is L plus A is the total length. L plus A is the total length of the stretched string. And what is the original length? Original length was A. So if I subtract that, that is nothing but the extension of this stretched string. That is equals to how much? That becomes L number. Okay. So corresponding to that, what is the spring force? So spring force is nothing but K into X. Okay. So that means K into L. Now what is K? K number is given as 2 mg by A. So that is 2 mg by A into L. So that is a string force. So that force is acting in this direction. That force is acting in this direction. So if I draw the free body diagram, so on this bead, so therefore one force is acting Kx in this direction. Let us say this angle is theta. So the component of Kx, which is balancing the vertical force, that is mg, small mg, that should be equal to Kx cos theta. So Kx cos theta is balancing that. So ultimately what you can write, Kx into cos theta, that should be equal to mg number. Now what is cos theta number? So from this triangle OBR, can I say cos theta equals to y naught by L? So ultimately what I am getting, Kx into y naught by L should be equal to mg. Now put the value of x. X is equal to 2 mg by A into L. So entire force is 2 mg by A into L. So 2 mg by A into L into y naught should be equal to our mg number then. Okay. So if I cancel all those numbers, so ultimately what I am getting, y naught equals to, now there is another L in the denominator. So y naught equals to A by 2. So I am getting y naught equals to A by 2. That is the at equilibrium, the bead is at a distance of y naught, that is equals to A by 2 from the point O. Now, in the second part, now the B is raised to point C, which is above the wire O point at point C. Let us, now the bead is at point C. What is the distance? That distance is given as A. Okay. So now the string is attached like this. This is the string portion. So total that, so CR length is A root 2 plus A. So now it is released from the race. Find the speed of the bead as it passes through point. So initially, so once the bead is at point C, so can I calculate what is the elongation part of the string? That x number should be equals to A root 2 plus A minus A, because A root 2 plus A is the final length and initial unstretched length was A. So ultimately I am getting A root 2. Okay. So A root 2 is the x number. So corresponding to that, if I say initial potential energy, that should be equal to half k x square. So half k into x square means A root 2 whole square. That means k into A square. That is the answer for the initial potential energy of the spring. Now ultimately it is being released. So initial kinetic energy at that particular position is also 0. because it is given that it is released. So I got the information about the EY and the KI. Now after releasing from point C, the bead is moving towards the point O. And once the bead is at point O, then what is the total length of the string? That is A plus A. This is the A. This is another. So total length is A plus A means 2A. So X becomes A plus A minus A. So that means it equals to simply A. So corresponding to that, final potential at U final should be equal to how much? Half K into A square simply. Now you are asked to calculate the K final. Okay. Why? Because the bead is passing to the point O. Let us say that this is passing into velocity V0. So corresponding to that, if I use the energy balance equation, so what I can write, K into A square plus 0 should be equal to K A square by 2 plus K final. Corresponding to the K final equals to how much? Simply K A square by 2. Now put the value. So K square by 2, K is how much? K is equals to 2 mg by A. So it is equal to 2 mg by A into A square by 2. So 2 cancels out. So I got mg by A. That should be equal to K final. That is equal to half m into V0 square. Okay. So mm cancels out. So V0 becomes how much? Under root 2g by A. So that is your answer. So this is the speed with which the particle B is crossing the point O. Hope you understand this. Now moving on to the next situation. So there is a particle suspended vertically from point O in extensible mass placed straight of length A. Okay. So this is the particle that is there. Now there is a vertical line AB is at a distance of L by A from the point O as shown. Now object is given a horizontal speed U. At some point its motion ceases to be circular and eventually the object passes to the line AB. That means if I throw the ball, let us say I am redrawing it. So this is the ball, let us say this is the M mass particle, you impart a velocity of U and it will start to complete a vertical circuit. Now U is not sufficiently hard so that it can complete the vertical circuit. That means U is basically less than root of 5GL. Okay, that means it cannot complete the vertical circle. But after some point of time, let us say from this point, at this point what is happening? The tension becomes 0 and that means it ceases to form the vertical motion. Now from this point onward it will perform the projectile motion. It is still V. Okay. So now during the projectile path, it has been given that it will pass through the line AB. Once the particle projectile path pass through the line AB and at the instant of crossing AB, its velocity becomes horizontal. So once the particle is crossing the line AB, let us say this is the line AB. So particle velocity becomes horizontal means what is happening? So here the particle is going like this, a projectile motion. Now here the particle velocity becomes horizontal. So that means it has only for the projectile path, it has only the x component of velocity. That means what you can conclude that this distance is basically our half range r by 2 and this is our basically the maximum height. Okay. So I can conclude that if I say the particle will perform the projectile motion from this point onward. Okay. So you are asked to calculate that value of Q. Okay. So for that, what you should do that first of all you have to know from where this is happening, that theta angle. So I can use the formula directly, that is cos theta equals to U square minus 2GL, you have a 3. That is the value from where the particle is performing the projectile motion. That is the cos theta value. Corresponding to that, I can also calculate the velocity of that particle. So if I apply the work energy theorem between point A and point B, let us say this is the point A and let us say that is the point B. I want to calculate what is the velocity if the particle is performing the projectile motion. So taking the A as the reference line, can I write half m into U square plus 0 should be equals to half into m into V square plus mgl plus mgl cos theta. That means mgl into 1 plus cos theta. That number. Okay. So if I simplify it, what I am getting that V square should be equals to U square minus 2GL into 1 plus cos. So that is the velocity if the particle is performing the projectile. Now I can put the value of cos theta and can simplify it. Okay. So from that I can get the value of cos theta also. if I solve this. Okay. So now the question comes is that what is the value of q? So your unknown becomes one is theta, another is q. So now there is another information that is given that corresponding when the part is performing the vertical motion. So can I say this angle is also theta? Because if I say there is theta, so this angle is theta. Means this is an idea when I theta, means this is theta. So original component of velocity is how much? V cos. Okay. Original component of velocity V cos theta. And corresponding to that, I can write the equation of two value of thing, that is one is the half range. So what is R by 2 number? What is R by 2? R by 2 is basically ux into 2 times of uy by g. That is the answer for the R by 2. That means I am getting ux into uy by g. That is one equation. Okay. Now what is ux? Ux is basically V cos theta. And what is uy? That is V sin by g. Okay. And what is R by 2 number? So from that, what I can write that R by 2 is what? R by 2 is L sin theta minus L by 8. L sin theta minus L by 8. Okay. So that is one equation. So from that, what I am getting that V square into sin square theta sin theta cos theta by g equal to this one. Okay. So this is equation number, let us say 2. And I can write another equation of motion that is equal to for the vertical height attained. So h is how much? What is the formula? That is uy square by 2g. Uy square by 2g. That number is h number. Okay. Uy square by 2g. So uy square. So that cannot be used. That is not essential. So forget about this. Okay. So from this three equation, I can get the value of q. So if I substitute the cos theta number from equation number 1 to equation number 2. Okay, let us use equation number 3. So I substitute the equation number 1 to equation number 2. So I am getting v square equals to how much? U square minus 2gl into 1 plus cos theta. So that is 1 plus u square minus 2gl by 3gl. Okay. So 3gl minus 2gl, gl, u square plus gl, u square plus gl by 3gl. So ultimately I am getting u square minus 2 by 3 into u square plus gl. Okay. So that means this is u square by 3 minus 2gl by 3 or u square minus 2gl by 3. That number. Okay. So this is the answer for the V. So once I put it over here, once I put it over there, so in equation number 3, what I can simplify is that V square equals to how much? So from equation number 3, u square minus 2gl by 3 is the V square number into sin theta into cos theta, sin theta into cos theta by g, that should be equals to L sin theta minus L by. Okay. So from this equation, if I simplify it, so putting the value of sin theta and cos theta together, what I can get the value of U. Okay, so that is the value of U. Okay, so you have to calculate it to get the value of. So only thing is that you have to understand the situation, how the part is following the path. So it is crossing the path AB in such a way so that at that point, the horizontal speed becomes 0. So only the vertical original speed becomes there, only the vertical speed is 0. That means you can also calculate what is the time for that. Okay. Hope you understand this. Now moving on to the next equation. Now there is a square plate which is firmly attached to a frictionless horizontal plane. Okay, so there is a square plate which is firmly attached to the frictionless horizontal plane. Now there is a point from where I throw a particle with the speed v0. Now if we perform the circular motion, ultimately it is given that it is returned to the point A again. Okay, so you are asked to calculate the velocity of the sphere when it reaches the point A again, and you are asked to calculate also the total time taken by the sphere to complete the circle. And entire thing is happening on a horizontal plane. So no effect of gravity. So what is happening over here? Let us say this is the plate. This is the plate which is fixed. So this is fixed plate. Okay. So this is point A, this is point B, then C, and then D. So once you throw the ball, let us say from point A So at a distance of 4a. So from here you project the particle to velocity v naught and distance of 4a. So taking a as a center, it will perform a circular track of like this. Okay, until unless it becomes straight. Okay, at this point, the particle will touch the point B. Now from point B onward, with the radius of 3a now, you will try to perform another circle like this. Okay, of radius 3a. So from point C, it will stop it, and again it will try to rotate in this direction with the radius of now 2a. So going down to that particular point where the radius becomes 2a, so let us say this is the radius 2a. Okay, and here from here onward, it will perform another circular motion where the radius is a. So now it will finally reach at this point. So since entire thing is happening in a horizontal frame of reference, so I can clearly say that there is no friction in the plate, and ultimately the ball will hit this in this direction with the velocity of v naught. Okay. Now you are asked to calculate the time. So for this part, let us say P to Q, then Q to R, R to S, and S to A. So for PQ, it will take the time. So how to calculate the time? So time of rotation equals to 2 pi R by V. Okay. So time of rotation equals to 2 pi R by V. So for the entire thing. But here every time it is performing a 1/4 of a circle. So that means basically I want to calculate the distance of 1/4. That means T by 4 now. So that is equal to pi R by 2V. Okay. So that will be the answer for the time code. So for T P to Q. So for T P to Q, what is the answer? So here the R is 4a. So pi into 4a by 2 into V naught. That means pi 2 times pi a by V naught. Now T for Q to R, pi into radius is 3a by 2 V naught. That means T pi a by 2 V naught. Then T R to S, that should be equal to pi, radius is how much? 2a by 2 V naught. That is pi a by V naught. And lastly, I can calculate the time for S to A path. That means pi R by 2 V naught. So pi R is how much? R is now a by 2 V naught. Okay. Now simply add these 4 numbers to get the answer of total time. Okay. So once I add those numbers, I can get the answer for the total time. So sum of all the time will give the total time. So that will be your answer. Okay. Now moving on to the next situation. Here there is a bob of simple pendulum of length L is released from point P. What is the angle made by the direction of net acceleration? Net acceleration of the bob with the string at point P. Okay. Initially, the bob is being released from point P. Now, once it is being released, it will move up to point Q. Now, at point Q, what is happening? The net acceleration comes into place. So, at point Q, let us say, here the value of tangential acceleration AT and radial acceleration AR in this direction. Okay. So, there were 2 accelerations. So, you are asked to calculate the angle made by the net acceleration with the bob, with the string basically. So let us say this is the A net acceleration. So you want to calculate this angle alpha. Net acceleration making how much angle with the string, that is alpha angle. Okay, so for that you have to calculate the AR and AT number, and correspondingly you can calculate the alpha also. So let us do this. So initially the particle is at rest. So once it comes to point Q, can I say the particle is moving with velocity that is equal to 2gh. Okay, so if I calculate the energy balance between these two, let us say at this point the particle is moving with the velocity v. So corresponding to do the energy balance between these 2 points, so I can clearly say that half mv square, that is equals to mg into h. Why? Because no other force is doing work. Tension and the centrifugal force are 0 work, basically giving no work, because they are perpendicular to the direction of motion. So from that, what you can write, v square equals to 2 times into g into h. So corresponding to that, AR is equals to how much? V square by L. L is the length of the string that is given. Okay. So that means 2gh by L. That is the AR number. And what is AT? AT is the tangential acceleration. Tangential acceleration is produced due to the mg sin theta component. So here the mg is acting downward at a defined angle theta. Let us say net force along this direction is how much? Mg sin theta. Okay. So corresponding to that, AT is how much? Force by mass. So mg sin theta divided by m, that will be the value of AT, that is g sin theta. Okay. So you know the value of AT, you know the value of AR. So now you are asked to calculate the angle alpha. Let us say I am taking the angle tan alpha. So what is tan alpha? Tan alpha equals to AT by AR. Now put the value AT equals to g sin theta, but AR equals to 2gh by L. So ultimately I am getting sin theta into L by 2h. Okay. Now h can also be represented in terms of the theta angle. Now what is that angle? So h is basically the vertical distance. So vertical distance is what? So L minus L cos theta. So initially the wall is over here. So that h is given. Now finally wall is there. So in terms of tan alpha, so ultimately what is the answer? So tan alpha can be written as sin theta into L by 2L. That is the answer. Because h is given. H is given. Okay. Now, in this situation, there is a rod of length 2L carries two equal masses small m. One is at the lowest position A and another at the middle position B. Okay. Now, the rod can rotate in a vertical plane about the fixed axis passing to the point C. What horizontal velocity must be imparted to the mass A? So here you want to impart a velocity of u so that it can just complete the vertical circle. So you are asked to calculate the u number. Now since it is a problem that the bodies are connected in the rod, so what you can ensure that at the maximum point, let us say this is the vertical circle that is the performing by the system. So here one mass is there, m mass, another mass is over there, n mass. Okay. So this is the point 2. So at the highest position, now the tension can never be zero because they are connected with the rod. So at this rod situation, T is not equal to 0. So only thing is that I can say that both the velocity of, let us say, A and B becomes 0. Velocity is 0. Linear component of velocity is 0. Okay. So that it will cross the vertical circle. Now once it starts the movement, so let us say here I am imparting the velocity of u. So corresponding to that, what is the value of v then? So v should be half of u. Because if I say they start to rotate with omega, so omega equals to what? V by r. So omega for A should be equals to omega for B. Both are equal. So omega for A equals to how much? A should be equals to u by 2L. That should be equals to ub by L. So ub becomes what? Ub equals to basically u by 2. So ub equals to u by 2. So particle B is moving with a velocity of u by 2 and particle A is moving with a velocity of u. So now I can do the simply work energy theorem analysis. So taking this is the reference line. So with respect to reference line, kinetic energy initial should be equals to how much? Half m u square plus half m into u by 2 whole square. Okay, so this is the kinetic energy initial. Similarly, potential energy initial is how much? So for the A body, there is no potential energy. So only for the potential energy is there for the B body. Now B body is at a height of L bar from this reference line. So corresponding to that, the potential energy, initial potential energy is equals to mg into L. Okay. Now similarly, kinetic energy final, that is equals to 0 because both the particles are at 0 speed location. Now potential energy. What is the final potential energy? Final potential energy should be equal to potential energy of A. So A is at a distance of 4L from the reference. So total length of the string is L plus L equals to 2L. So it should be at a distance of 4L. So 4 mgl plus potential energy of B. So potential energy of B is 3L. So from this point to this point, this distance is 3L then. Okay. So 3L. So 3 mgl. So that means total potential is 7 mgl. So now I can equate these two numbers. So once I am equating these two numbers, what I am getting that half mu square. So here I can simplify it. So that is mu square by 4. If I take half common, half a mu square take common, so it should be 1 plus 1 by 4. So that means 5 by 4. So 5 by 4 into a mu square by 2, that is the initial quantity. So that means 5 by 8 a mu square plus mgl should be equal to 7 mgl. 7 mgl is the final potential energy. So ultimately what I am getting, 5 mu square by 8 should be equal to 6 mgl. So cancel m. So what I am getting, that u square should be equal to 48 gl, 48 gl divided by 5. So finally u should be equal to under root of 48 gl by 5. So that is the answer. Okay. So you have to impart a minimum series of 48 gl by 5 root, so that the part will complete the vertical circular motion. Okay. Now, there is another situation where there are two identical rings which can slide along the rod are kept near the midpoint of a smooth rod of length 2L. Okay. So this rod is rotating with a constant angular speed omega with the vertical axis passing through its center. The rod is at a height h from the ground. So this is height h from the ground. Find the distance between the points on the ground where the rings will fall after leaving the ground. Okay. So at any instant of time, so first of all, let us check at any instant of time the ring is over here. Ring is over here. So since there is no friction force, only force that is pulling the ring out of the rod is basically due to the centrifugal force, that is m omega square into x. What is x? X is the distance of the ring from the rod itself. So corresponding to that, what is the acceleration? Acceleration equals to m omega square x divided by m, that is omega square into x. Okay, so acceleration equals to omega square x. Corresponding to that, what is the velocity? So a can be written as v dv dx. That should be equal to omega square x. So ultimately what I write, v dv should be equal to omega square x into dx. Now if I integrate both sides, so integration of v dv should be equal to integration of omega square x dx. Now limit is from 0 to v and 0 to l. So omega square l square by 2, that's equals to v square by 2. So ultimately what I am getting, v square equals to omega square l square, or v should be equals to l into omega. So this is the velocity which is the ring is coming out. But since now once the ring is coming out with the tangent velocity of l omega, so ring is also rotating. So it has another component of velocity which is in this direction. Okay, because of the rotation of the rod. So what is that velocity? That is also equals to omega into L. This is the tangential component. So that means at this point ring is basically ejecting with this kind of velocity. Okay, with this kind of velocity. Okay, similarly, once the other ring is ejecting out from this system, so it has a velocity, ring has a velocity in this direction, which is equal to L omega. But since the rod is rotating, so due to that, it will get another omega into L in this direction. So resultant of this to get this direction velocity. Okay. So ultimately both are moving in the opposite direction with some angle, which is angle is 45 degree. So ultimately it will fall a projectile path in this direction. So that will fall in the projectile in the other direction. So you are asked to calculate that distance between them. So let us do this in a 3D way. So what is happening over here? Let us say I am saying this is the plane. This is the plane, XY plane, let us say. Here the rod is located and rod is like this. So this is the rod. Okay. So rod is rotating in this plane. So let us say I am saying this is the Z axis, this is our X axis, these are X axis and these are Y axis. X axis and Y axis. Okay. So these are X axis. So once the ring is ejecting from this point, so it has a velocity along X direction in this direction, so to Vx. Another velocity comes due to the rod in the Y direction, negative Y direction, in this direction, Vy. Okay. So because of that, the ring will fall at a particular position on this plane like this. Yeah. Okay. Similarly, the other ring will do the same thing, but in the opposite direction. Here, the Vx is in this direction. Vx is in this direction, and Vy is in this direction. So ultimately, the ring will fall over here. So these are the 2 points where the ring will fall. So according to the coordinate system, if I say the first one is falling on the first quadrant and the second one is falling on the third part. Okay, now only thing is that you have to get the coordinate of these 2 points. Now how to get that? Now taking, this is the origin. So I am taking, this is the origin point. So can I say that t time for both the rings, so to reach the ground, is basically equals to under root 2h by g. So t equals to under root 2h by g. After that time, it will fall on the ground. Let us say I am saying this number is t0. Okay. So if I say this is t0, so along x distance, the particle will move by a distance of this much, that is equals to, let us say this coordinate is, this number is x0 number. So what is that number? That is the distance traveled by the ring in the x direction, that is equals to Vx into t0. Now, see, we can simplify it in further way. Since Vx and t0, Vx and Vy both are equal, let us say that number is equals to, let us say V0. Okay, so that distance is V0 into t0. Similarly, the y coordinate is also V0 into t0 in this direction. Okay, so finally, this coordinate can be written as, so that part you have to add it. So this is the what part? This is the x part. This is equals to L. So final, let us say this is the P1 point. So can I say the coordinate of P1 is L plus V0 T0, comma V0 T0. Okay. So this is the coordinate of the P1 point. So this is the coordinate of the P1 point. Similarly, coordinate of P2 point will be how much? P2 point will be similar to me. So both will cover the equal distance in x and y, but the x coordinate will be how much? X coordinate for the P2 point here, for this P2 point, x coordinate will be negative. So it should be equals to minus times L plus V0 into T0, and y coordinate is also negative, minus V0 into T0, because it is lying in the third quadrant. So simply, I want to calculate the distance between the 2 points whose coordinates are given by this thing. So that means I want to calculate this distance. So the diagonally, this distance I want to calculate. So that means the coordinate should be added up. Okay. So this number minus this number is plus L plus V0 T0 whole square plus V0 T0 whole square, that is the distance. So P1, P2, that distance is equals to how much? Square root of, so 2 will come out. So L plus V0 T0, square of that number, plus V0. Now you can V0 T0 whole square. Okay. V0 T0 whole square. So now simply you can put the value of V0 and T0, whatever the value that I am getting. So that number is nothing but I represented it by V0, and T0 is also given to you. So you can put it over there and simplify it, so you can get the answer. Hope you understand. So this is the classical problem in 3D dimension. 3-dimensional problem. So where the component of both velocity along x and along y will be. Okay. Now moving on to the next situation. Here there is a bus which is moving with a constant acceleration of this much. A equals to 3g by 4 towards right. The bus is moving towards right with an acceleration. Now in the bus, a ball is tied with a rope of length L and is rotated in a vertical circle inside the train. So you are asked to calculate the angle theta for which the tension in the rope will be minimum. So in this situation, what is happening? Let us say the ball is performing a circular motion, and on the ball there will be a pseudo force. On the ball there will be one pseudo force. Now you are asked to calculate the value of theta at which the tension in the rope will be minimum. So I know that for a vertical circuit, tension will be minimum. That is, tension will be 0 at a point where the speed is minimum. At a point speed is minimum. So for this situation, let us say the string is at this position where it is feeling a value of tension which is minimum. So corresponding to that, I can say here this is the location of the minimum position of the tension. Okay. So diametrically opposite point will be the point where the tension is maximum. Okay. So the point where the tension is minimum, so diametrically opposite point will give the value of tension which is maximum. Now, so at this position, what is happening? So mg is acting downward, and here the pseudo force will come into the picture. That is m into 3mg by 4. Okay. So because of that, the tension will be in this direction, which is maximum. Because of this, the tension is maximum. So if I say this is angle, so you are asked to calculate that angle theta. Okay, so that angle theta means this angle is theta. Okay, so for this equation, what I can calculate that these two forces should be balancing each other. Why? Because that is the same position, where the minimum position is there. So where I can say the tan theta should be equal to how much? mg divided by 3 mg by 4. Okay, that is 4 by 2. That means theta equals to 53 degrees. So this is the angle made with the vertical or made with the horizontal, so that at this point the tension will be minimum. Why? Because at this point only the two forces are existing. One is mg and m pseudo force, that is m into a. Okay, so that means it is balancing the situation such that the tension at this point is becoming 0. So corresponding to the first point is basically 53 degrees. Now, at the above mentioned position, find the minimum possible speed V minimum during the whole path to just complete the circle motion. Okay, so I know that once the tension becomes minimum, at this point the velocity will be minimum. Here the velocity will be minimum. If I draw the free body diagram for this particular situation, so then what I can say, the tension minimum is how much? That becomes 0. Okay, so now at the inclined position, let us say at this position, if I draw the free body diagram again, certain angle theta, now the string is in this position. So here I know that on this particular string there is a one force that is acting in this direction, that is equals to m into a, that is 3 mg by 4. Another force is mg is acting over here. Okay, now at that instant if I say velocity is v, so corresponding to that this is the mv square by L number or mv square by L number. Okay, nice. Now I know this is angle theta. Now take the component. So mg has sin theta component and 3 mg by 4 is the cos theta component. So can I write mg sin theta plus 3 mg by 4 cos theta? That should be equal to mg square by L number. Okay. Now simply put the value of sin theta and cos theta. So I have already calculated the value of theta. So that is 53 degrees. So sin theta means 4 by 5. So 4 mg by 5 plus 3 mg by 4 into cos theta. Cos theta means 3 by 5. That should be equal to mg square by L number. Okay, so that means LCM is 20. So 16 mg, 16 plus 9 mg, that should be equal to mg square by L number. Okay, so 25 by 20, so means 5 mg by 4. That should be equal to mg square by L. So cancel the m number. So ultimately what I left is v square equals to 5 gl by 4. 5 gl by 4. So v should be equals to root of 5 gl by 2. So this is the velocity at minimum position. Minimum position is the tension, where this minimum. Now you are asked to calculate the for above value of V minimum, find the maximum tension in the string during the circular motion. That means at maximum position, what is the tension max that you want to calculate. So for that, let us say the particle has been projected with the velocity of u. Now for that, the particle has been projected with the velocity of u. So from the energy balance, I can calculate the value of u, so that I can use that to calculate the tension. Okay. So what is the answer for the tension will be? So T max should be equals to how much? This mg sin theta. So same theta. So mg sin theta plus 3 mg by 4 cos theta. That means how much? 5 mg by 4. That is already there. So I am writing simply that T max should be equal to how much? 5 mg by 4. Why? Because once I do the component analysis, 3 mg by 4 will give the cos theta. Mg by mg component will be the sin theta. So plus mu square by r. Mu square by r. That is your answer. Okay. Now only thing is that you have to calculate the u number. So in order to calculate the u number, you have to apply the work energy theorem between point. Let us say this is the point A and this is the point B. So between A and point B. Okay. So you have already calculated the V number. So V is how much? 5 GL by 2. Okay. That is the kinetic energy at that point is known. And work is done by the pseudo force also. Pseudo force is there. That means work is done by the pseudo force. You have to take it into consideration of that. Now, in this situation, there is a small body of mass M is allowed to slide on an inclined frictionless track from rest position A as shown in the figure. Okay. So find the minimum height H so that the body may successfully complete the loop of radius R. Okay. So in order to complete successfully the loop of radius R, the minimum speed at this position should be how much? Should be root of 5gr. Okay, that is the minimum requirement speed, U minimum, for the particle to complete the vertical circle. So that is the condition. So kinetic energy corresponding to that situation should be equal to half m into 5gr. That should be equal to mgh number, potential energy. So if I calculate m, if I calculate the h number, so h should be equal to how much? 5gr by 2 g. That is 5r by 2. H should be equal to 5r by 2. So from this height, the particle has to drop so that it can complete the vertical circle. Okay, and once it is complete the vertical circle, so minimum condition is that at that particular point at h, the normal should be equal to 0. Okay, normal should be equal to 0. Now in the second situation, the h is double. So minimum height of that minimum. Okay, so initially what we calculate that h is equal to 5r by 2. Now in the second situation, it is equal to simply 5r. So from the height of 5r, you drop the particle, find the resultant force on the block at position h. So once the particle is performing the vertical circular motion, at point h, now the normal is not equal to 0. So here the particle has a velocity of mass of mg. So let us say the particle has a velocity v over here. Okay. So corresponding to that, there is one mv square by r forces they are acting in the opposite direction, and normal is acting in this direction. So at this situation, what is happening? So you are asked to calculate the normal value. That should be equal to how much? mv square by r minus mg. So for that, you should calculate the value of v. Now, in order to calculate the value of v, let us say the particle is released from point over here. The particle is released from point over here. So the distance that has been dropped by the particle is how much? This much. That is how much? That is equal to h minus 2r. That is equal to 5r minus 2r. That is equal to 3r. So due to these, the potential energy is being dropped by 3mgr. That is the gain in kinetic energy. So 3mgr is the drop in potential energy. That is equal to gain in kinetic energy equal to half mv square. Okay. So that means v square equals to 6gr. So put that number. So if I say v square equals to 6gr, so 6mg minus mg. That means at that particular point, n is equal to 5 times mg. So this is the normal force acting on the particle if the same particle is released from a height which is double that the previous one. Okay. So once I am releasing the particle from a greater height, now the normal is not equal to 0. Initially calculate the value of h equals to 5r by 2, where when the normal becomes 0 at that particular. Okay. Now moving on to the next situation. So there is a particle of mass m is suspended by a string of length L from a fixed rigid subject. A horizontal velocity v0 equals to root 3g is imparted to its surface. Okay. So if I say this is the particle which is fixed to the point O and you impart a velocity v0 that is equals to root 3gl at the minimum position. Calculate the angle made by the string with the vertical when the acceleration of the particle is inclined to the string by 45. So particle performing the vertical circular motion. So let us say at any instant, you are getting the feeling that the AT is in the, so as the particle is moving upward, so particle is going to reduce its velocity. That means the tangential acceleration will be in this direction AT. Okay. And AR is always acting toward the center. AR. Now the NA, so angle made with the string with the vertical, when the acceleration of the particle is inclined to the string is 45. So that means at this position, let us say this NA is acting in this direction. So this angle is given as 45 degree. Okay. NA is making an angle 45 degree with the string. So that means AT and AR must be equal. That means at this location, what you can say, AT number is equals to AR. Okay, AT number is equals to AR. So what is AT? AT is simply basically G sine. So you are asked to calculate that theta angle also, this theta angle. So AT is G sine theta. G sine theta. And what about the AR? So for AR, Let us say at this position velocity of the particle is v dot v. So if I do the work energy theorem between this point and this point A and B, I want to write the work energy relation between point A and B. So initial kinetic energy is equal to half m v naught square. Potential energy is 0. That should be equal to half m into v square plus potential energy. So mg into, so that is equal to L minus L cos theta. Why? Because this is L cos theta. So this number is L cos theta. So total L minus L cos theta. So mgl into 1 minus cos theta. Okay. So now m sub cancels out. So what I am left with? So v naught square equals to v square plus 2gl into 1 minus cos theta. Okay. So now put the value of v naught square equals to 3gl. So 3gl equals to v square plus 2gl into 1 minus cos theta. Now take the side chain. So v square should be equals to how much? gl minus plus 2gl cos theta. That means gl into 1 plus 2 cos theta. So that is the v square answer. Okay. So now substitute the v square number to get the value of AR. So AR is how much? AR should be equal to v square by L. So that means g into 1 plus 2 cos theta. That is the AR number. So according to the problem, the AR and AT must be equal. AR and AT equal. So g plus 2 cos theta equals to g sin theta. That is the equation that we have to solve it. So cancel g from both sides. So what I am left with is equal to sin theta minus 2 cos theta, that is equals to 1. Okay. Now you have to solve it from the solution of the trigonometry. So if I divide both sides by root 5, so I am getting 1 by root 5 sin theta minus 2 by root 5 cos theta. That should be equal to 1 by root 5. Let us say I am taking 1 by root 5 number is equals to cos alpha. Cos alpha. So 2 by root 5 becomes sin alpha. Okay. So that means sin theta cos alpha minus cos theta sin alpha means sin theta minus alpha. Sin theta minus alpha. That should be equal to 1 by root 5 means cos alpha. Okay. So what I can say, that is equals to sin of 90 minus alpha. Okay, 90 minus alpha. That means theta becomes 90 degree. Theta becomes 90 degree. So from that, what I can get, the value of theta is equals to 90 degree. That is the answer. Hope you understand this. Now there is another situation. There is a particle is performing a circular track of radius 1 meter. Speed is v equals to 2t square given. So what will be the magnitude of acceleration at t equals to 1 second? So since you are asked to calculate the magnitude of acceleration, because it is a net. So I know that v should be equals to 2t square. That is the tangential speed or velocity. So correspondingly, what we can write that if I perform the dvdt, so dvdt is equal to value of 80. 80 is equals to how much? 40. Okay, 40. So corresponding to 80, what we can write that 80 equals to basically r into alpha. So r is how much? Given as 1 meter. So corresponding to that, what I can calculate the value of alpha as equals to 40. So alpha is the time variation. So that is equals to d omega dt then. Okay. So omega should be equal to 40 dt. Integration. That is t square, 2t square again. 4t square by 2 means 2t square. So omega equals to 2t square. So at t equals to 1 second, at t equals to 1 second, omega equals to how much? Omega equals to 2. Corresponding to the AR equals to how much? Omega square by r. Omega square into r. So omega square is 4 meter per second square. Okay, so I am getting the value of AR as 4 meter per second square. Similarly, at t equals to 1 second, what is 80? That is 40. For t equals to 1 second, this 80 becomes how much? This 80 is also 4 meter per second square. So corresponding to that, the n8 is how much? n8 should be equals to under root of AR square plus 80 square square root. That means 4 root 2 meter per second square. So that will be your answer. Okay.